In this video, we're going to analyze what we've learned from the derivation and from the analysis of the model. We've realized that the quantity beta n over mu plays a significant role in the behavior of the disease. We've seen that when this ratio of constants is greater than 1, the disease becomes endemic, which means some proportion of the population will always be sick. When the ratio of this constant is less than 1, the disease will be wiped out and everybody will return to health. We will refer to this ratio of constants as R0. What is R0? R0 is called the basic reproductive number of the disease. R0 is basically equal to the number of new infections caused by one infected individual during the course of their illness. Now, let's talk a little bit about where R0 comes from and how we can understand what it means. First of all, let's analyze the units in this differential equation. Every single one of the terms has to have units of number of people divided by time. So that means that beta, in particular, the constant sitting here, must have units of per person per unit time in order to make this whole expression have the correct units. We see that mu, the constant sitting up here, has to have units of 1 over time. So the reciprocal, 1 over mu, is going to have units of time. In fact, 1 over mu represents a typical time scale that the person stays in the infected class, i.e. the duration of the infectious period. Now let's think about beta. We said that the constant beta has units of per person per unit time. Therefore, beta multiplied by n has units of 1 over time. And this is the rate at which new infections occur for each infectious individual in a population of size n that can get infected. So therefore, beta n is the rate that new infections occur per infectious individual. So R0 is going to essentially be the number of new infections that can be started by one individual during the course of their illness. And this explains both the form of the parameter R0 and its meaning.